May the 4th. Yes, I'm ready for any question, please.
So for the linear function, f of x equals m of x plus b.
F of x equals mx plus b?
Yeah.
Good. This is the slope-intercept form.
Right.
Good.
And then the f of -3 equals 14. And then f of 5 equals -2. Find m and b.
Good. So what does this mean? And what does this mean? When we say that f of -3 is 14, what does that mean?
That's the solution, right?
Thank you. I didn't get it. Yes, let's say it again.
The solution?
No.
Plug -3m for x.
Thank you very much. -3m plus b equals 14, and 5m minus plus b equals -2. Awesome. Exactly. That's exactly what it means. When I plug in -3 for x, I get y equals 14. So excellent example. So we have a system with two linear equations in two variables. So I'm going to multiply the first equation. Let's write the system one more time. -3m plus b equals 14, and 5m plus b equals -2. And let's say we multiply the first equation by -1 because we are trying to eliminate b. So this is 3m minus b equals -14. We multiply all terms, both sides, by -1. We copy, remember when we use elimination, we have to keep the equations together. We copy the second equation, and we met our target, at least for now. This is 8m, and this is -16. And when we solve for m, we get -2. This is good, but it's not good enough. I have to find b. So I go back here and replace m by -2. -10 plus b equals -2 means b equals 8 when we add 10 to both sides. So I claim that the solution is -2, 8, but it's good, but it's not good enough. I'm going back. I don't need anyone to tell me whether that's correct or not. I'll go back to the original system and make sure that this is okay. So I claim basically that the function is -2x plus 8. Oops. -2x plus 8. And now I'm going to plug in -3 to make sure that I get 14. -3 times -2 is +6, plus 4 is indeed, plus 8 is indeed 14. Now I'm plugging in 5. 5 times -2 is -10. -10 plus 8 is indeed -2. And I'll say, yes, I checked. It was a very good problem. Thank you. Perfect question. Next question, please. Anything? Anything you tried? Anything you worked on? Anything. Give me anything. Anything?
I think I'm good.
Is this okay? Anything? Is this okay? All steps on this problem? Okay, 6.1 then. We have 6.1, and 8.1 left. In 6.1, as I warned you last time, it's going to take me a while to explain step by step solving systems of three linear equations in 3 variables. So solving systems of 3 we call them 3 by 3. Three equations, 3 variables. I want to add a word here which is very important, linear. Solving linear systems of 3 by 3, 3 equations, 3 variables, using a method that we've never talked about before, Gauss-Jordan. Solving systems of 3 by 3, meaning 3 equations, 3 variables, they are linear systems. All equations are linear, no x squared, x cubed, or anything like that, using Gauss-Jordan. There are a lot of steps here to talk about. Let me first copy a system. I'll copy a system from your book because I can make one up. I mean, I can, but I don't want you to wait. So on page 631, I like to start with 22. X minus 2y minus z equals 2. 2x minus y plus z equals 4. Negative x plus y, minus 2z equals negative 4. So I can put this away. Okay. As we see, this is a system of 3 linear equations.
That's a Z, correct?
Yeah, I'm so sorry. You want me to change it? My Z is not very readable.
No, it's fine. It just was a little blurry. That's why I was asking.
Yeah, I'm sorry. Can I change this a little bit, do you think? Is this better?
Yeah, it's fine.
Sorry about that. I ordered a Wacom tablet this morning. It's not coming till Sunday. Hopefully that will be better when we start reviewing. So, but I can't get it before Sunday. Sorry, my apologies. I thought that this setup would be better, but I talked to a friend of mine from physics, and he said that I should try something else. Okay, so I will. So as we see, these are 3 equations, and we see 3 variables. The system, when I get it ready for Gauss-Jordan, the system has to be presented like this. All x below x, all y below y, all z below z, the equal symbol below the equal symbol, and the free term at the end, on the other side of the equal symbol. First, we would like to identify the matrix of the system. First of all, you should ask, and I know you're asking, what is a matrix? A matrix is an array of numbers. Examples. We use huge brackets. Here is an example. 2, negative 3, 4, 1. So it has 2 rows and it has 2 columns, and that's an array, and we normally call it A, or we call it B, or we call it C. Here is another one. This one has 3 rows and 3 columns. Here's another one. This one has 3 rows, but only 1 column. Okay, but what is the matrix of the system now? The matrix of the system consists of all coefficients that we see with a bar representing the equal symbol, basically. What do I write? I write 1, 2, negative 1, coefficients corresponding to x. I write negative 2, negative 1, 1, coefficients corresponding to y. Negative 1, 1, negative 2 corresponding to z, and then 2, 4, negative 4 corresponding to the free terms. The notation for this, however, is something like this. And you can say, where do you come up with this? Well, where the equal symbol should be, this bar is the same here. What does A represent? A is only the coefficient matrix. What's coefficient matrix? Well, it's only the coefficients of the variables, not the free terms. Okay? So 1, 2, -1, -2, -1, 1, -1, 1, -2. When we add the free terms, which obviously this time we are going to denote this by, it's very rare that we denote the matrices by lowercase letters, but that's fine. Anything is possible. It's just a notation. So this is also called the augmented coefficient matrix. What does that mean? It's augmented by the free terms, what we have on the other side of the equal symbol. Okay, so now you can say, very, very interesting, but why, what is this used, how is it used, and what's the method that we need to discuss? Okay. Knowing now that this is the coefficient matrix and this is the augmented matrix and also called the matrix of the system, here is what we want to do. We would like 1, -2. I'm just copying it because I want to have it here. We want this matrix. We will never be able to write the equal symbol here. Only this an arrow. They are not equal. I want to be able to change this matrix into something like this. And I'm just going to put some symbols here. So if I manage to change this into this, what conclusion do you draw? So before you answer, let me just say one more thing. I want to say, can I go back to the system from here? Of course I can. X minus 2y minus z equals 2. 2x minus y plus z equals 4. Negative x plus y minus 2z equals -4. What does this mean? If I manage to, through a sequence of steps, through a sequence of operations, if I manage to present this like this, what is the conclusion? So let's see what is the scope of doing this? What is the purpose? So if I manage to change this matrix into that, what is the conclusion that we draw?
Yeah, does it follow a pattern?
Exactly. But we conclude that, what is this? It's 1x, correct? This was x minus 2y minus z equals 2. So if these are gone, what does this mean? That x equals that number, whatever it is. What does this mean? That y
Equals -1.
equals this
Or
number, whatever that is. I don't know. I didn't calculate these numbers. That's why I just put some symbols in there. And then what does this mean?
That z
Equals
whatever
what exactly? That's all you need to do. We want to change this matrix into that, and then we will read the solution. X will be this number, Y will be this number, Z will be this number, because everything else is 0. So there is nothing that I can do with these zeros, right? X becomes that number, these are 0, Y becomes that number, and Z becomes that number. That's the purpose. But to get from here is not a piece of cake. It requires steps. Okay. So there are only 3 allowed operations in a matrix of a system, in the augmented matrix or in a matrix of a system. On this one, we only are allowed to apply 3 operations. The first 2 are common sense. The third one needs me to dig up what I just put in the recycle bin to have it ready, because I need to show something from the previous lecture. Okay, so here's my first question. If I decide to swap these 2 equations, for whatever reason, I want to put this equation first and this equation second, do you think that that will change the solution? Is it allowed? It doesn't matter. If I change these 2, if I put them in any order, the solution will never change. So I'm allowed to swap rows if that helps, if I need to. Second step, second operation that I'm allowed to is multiply or divide a row, any row. When I talk about a row, I talk about an equation, by a number that is not 0. Have we done that before? Many times. We multiplied an equation by 2 to get 6x minus 2y equals 2. That is absolutely allowed. I'm allowed to multiply or divide any row by a number that is not 0. Now the third operation that is allowed, I would like to go back and illustrate with something we did here. And then we can start the method. So look what we did on a particular problem last time. I don't even remember what it was all about. It was a word problem or not. It doesn't matter. So we decided to multiply both sides by -10. And then we added the new equation. We added, right? -10x, -10y, -2000. We added this equation to another one. And what we got was this. So this comes from elimination or adding method. We are allowed to multiply any equation by a non-zero number, add the result to another equation, and get a new one. And that's exactly what we're going to do. However, it will look differently, but this is what we're doing. So let's write it down. So the first one, we are allowed to swap rows if we want to. Then we are allowed to multiply or divide any row by a non-zero number. And the last one is multiply a row by a number that is not 0, and at the same time, same operation, add the result, like we did with elimination, to another row. So these are the only 3 operations that we are allowed to perform, and you'll see the sequence. Now this is the key. The sequence of steps for Gauss-Jordan. Sequence of steps for Gauss-Jordan method. Okay, good. I don't care what it's here, any number you want, it doesn't matter. The sequence of steps This must be number 1. We have to determine or get a 1 in the first row, first column. The entry in the first row, first column is this. We have to get a 1. In the next step, we get the corresponding zeros under 1. In step 3, obviously we have to get the 1 of the next column. In step 4, we have to get these 2. In step 5, we get the 1 of the column. And final step, we get the corresponding zeros. So what you need to remember is 1 and then the zeros. 1 and then the zeros. 1 and then the zeros. 1 is always first, and then the corresponding zeros. 1 of the second column, and then the corresponding zeros. 1 in the third column, and then the corresponding zeros.